Hey folks, in this video we are going to look at the rest of the chapter 7. So first of all, we are going to look through some practice problems on this method and shell method. And then after that, we're going to talk about arc length. So let's get started. Example 194. Use the most efficient strategy to compute the volume of the solid of revolution obtained by rotating about the x-axis the region bounded by x plus y equal to 3 and y equal to x squared plus 1. Alright, for sure, you need to draw the graph of x plus y equal to 3 and y equal to x squared plus 1. Alright, so we're gonna draw the axis first. X-axis and y-axis, good. Now we're gonna plot x squared plus 1. So y equal to x squared plus 1. So this is just parabola. Shift up 1 unit. That is easy. Alright, now we're gonna look at x plus y equal to 3. This is going to be our line. Right? It's just the line passing the point. The intercept is going to be 3, 0 and 0, 3. So we're gonna say that it's from the line. So my scale is not that good, but I'm gonna say this is my line x plus y equal to 3. It's past the point 3, 0 and 0, 3. Alright. Well, you can see that the bounded region is going to be the one that I just highlight in light blue. Alright. So now the question is, we need to find the volume of the solid of revolution obtained by rotating this region about the x-axis. So that means our axis of rotation is going to be x-axis. The question didn't say anything about the method that you want to use. Well, you can use this method or shell method, whatever you want. So first of all, you can see that to rotate about the x-axis, the easier way is you draw the vertical line here. Does it make sense? Because if you draw the vertical line here, so you don't have to split the region. Because if you draw the vertical line here, you can see that every time you're going to start from the red curve, which is going to be your y equal to x squared plus 1, and it goes to the green curve, which is going to be just x plus y equal to 3. You can see that the vertical line works in the way that the green one going to be at the top and the red one going to be at the bottom. You don't have to split the region. So if you do the vertical line, it is better. Well, I'm going to note here that the region is best treated by drawing a vertical line. Which means if you want to do a vertical line, so it's going to be perpendicular to the axis of rotation. So that means we should use this method, right? Here, because the axis of rotation is just the x-axis, well, you have a hole inside your solid. So that means this is actually the washer method. So you have to figure out the outer radius and inner radius, and then you can set up the integral. Alright, so if you want to draw a vertical line, then you can see that your big R gonna be the one that you start from the axis of rotation, and then you just goes to the uh, green one, which is the outer radius. So I'm gonna say my outer radius, this is big R. This is going to be the top line, which is y equal to 3 minus x. So 3 minus x, and then minus the bottom line, which is 0. So 3 minus x. And then the inner radius gonna be the one that you small r, the one that you have here. I'm gonna use the blue color here. This is this small r, right? Every time you get this, just small r. So that means the small r gonna be x squared plus 1 minus 0, which is x squared plus 1. So to set up the integral, so the volume that you want, this is going to be integral from A to B. So you have to find the intersection. So I'm going to skip that part first. So it's going to be pi the big R square minus small r square, the x from A to B. So that means you need to find the intersection first. So let's find the intersection. So we have x plus y equal to 3, and we have y equal to x squared plus 1. So that means you have 3 minus x equal to x squared plus 1. And that means you have x squared plus x minus 2 equal to 0. So this means you have x minus 1 and x plus 2 equal to 0. So solve this thing so you have x equal to 1 or negative 2. So that means your intersection gonna be when x equal to 1 and x equal to negative 2. So when x equal to 1, so you plug in into the function, so you get y equal to 2. And when x equal to negative 2, so you plug in, so you get y equal to 5. Those are two intersections here. So I'm going to highlight in yellow first. What you need for this question is you need integrate with respect to x. So it's going to go from negative 2 to 1. And then pi, the big R going to be 3 minus x, right? Small r going to be x squared plus 1. So after you plug in everything, this is going to be your final integral that you want. And you can integrate this by yourself. So the answer is going to be 117 pi over 5. All right, that is example 194. So we're going to move forward to the next one. So the next one is example 195. So I let R be the region bounded by parabola y equal to x squared, hyperbola xy equal to 1, and the line y equal to 4. So you need to draw the picture first, and then the question asks you to set up but do not evaluate the volume of the solid obtained by rotating R around the axis x equal to minus 2. Alright, we're gonna draw the picture first. So y equal to x squared. We have that. And then hyperbola xy equal to 1. So this is actually hyperbola, right? And then y equal to 4, which is like y equal to 4. So you can see that you can focus only on the first quadrant, right? Because the region bounded by the parabola, the hyperbola, and the line is just the one that I highlight in yellow. So this is going to be the focus region that we want. So we're gonna delete the picture on another quadrant. All right, so this is a clean picture that we have. So now the question asks to rotate this region about the axis x equal to -2, which is the dashed line here. So if you want to do this, so you have two ways to do it. So you can do the shell method or the disk method. So let's suppose that you want to use the disk or watcher method. So if you want to use the disk or watcher methods, so what you want is you want to cut the region perpendicular to the uh, axis of rotation. So the axis of rotation is here, x equal to 2. Well, if you want to do this by using this method, so you have to form the horizontal line. And that means you have to use the Washer method. So your volume gonna be integrated from a to b pi big R square minus small r square dx or dy, sorry, it must be dy because it's horizontal line, right? And then now you have to figure out the outer radius and the inner radius. So the outer radius big R gonna be from the axis of rotation to the red one, right? The axis of rotation to the red one. The axis of rotation to the red one. This is going to be your big R. So that means your outer radius gonna be, so first of all, your answer must be something in terms of y because you integrate with respect to y. So y equal to x squared here gonna turn to x equal to square root y. Alright, that means the outer radius gonna be square root y, which is the red line, minus the axis of rotation, which is -2. So that means this is square root y plus 2. Does it make sense? It's go to, well, again, one more time, it's going to go from axis of rotation to the red one, axis of rotation to the red one. For the inner radius, it's going to be the axis of rotation to the blue one, to the blue one, to the blue one. So that means your inner radius going to be the blue one, which is x equal to 1 over y. And then minus 2, which is 1 over y plus 2. All right. So this Watcher method gonna give you integrate from something to something, pi the big R now it's going to be square root y plus 2 square, then minus small r, which is going to be 1 over y plus 2 square, and then dy. And then what is going to be your lower bound and upper bound here of the integration? So we have to find the intersection. So I'm going to do it here. Intersection. So you have y equal to x squared and xy equal to 1. Well, again, if you can eyeball it, you can eyeball it. Well, it's going to be 1 and 1. But, well, if you want to actually solve, so you're going to have, going to replace y equal to x squared here. So you're going to have x times x squared equal to 1, which is x cubed equal to 1. So that means you solve, then you get x equal to 1, which means y equal to 1 as well. All right, that is the intersection with the red one and the blue one. So another two intersection is going to be x equal to, well, y equal to 4 here. So x equal to 2, and that is x equal to a quarter and y equal to 4, right? All right, that is our intersections. So to integrate dy here, so you're gonna integrate y from 1 to 4, right? Because you have to draw a horizontal line starting from 1 to y equal to 4. All right, that is the answer for this question. Sounds good? You can see that this method or the washer method, this is a good method to do for this question, because if you plan to do the shell method, you have to cut parallel to the axis of rotation, and that means you have to do the vertical line, which is going to give you a harder time because you have to split the region into two pieces, because on the left hand side from x equal to 1 over 4 to 1, you have to integrate from the blue curve to the green curve, and then after x equal to 1, so you integrate from x to the from the red curve and then to the green curve, which means if you use a shell method, you're gonna have the integral of two terms and then plus together. Does it make sense? Which means it is going to be a little bit harder because you have more complicated terms. All right, so we're gonna move to the next one. Example 196. So this is going to be the same picture, right? Because the question say we want R to be the region bounded by parabola y equal to x squared, hyperbola x y equal to 1, and line y equal to 4. So the same picture. However, the difference is we are going to set up the integral now, but to find the volume. But now we are going to rotate it around the axis y equal to -2. So we're gonna copy the picture from the previous equation. And now we are going to switch our axis of rotation to y equal to -2. 1 second. Alright, we're gonna switch our axis of rotation to y equal to -2. So you can see that the region is easier to treat as uh, the shell method. Why is that? Because it is easier to do the horizontal line, right? Because you don't have to split the region. And if you do the horizontal line here, that means you're trying to do the parallel cut with respect to the axis of rotation. Well, that means for this question, rotation. 1 second. All right, for this question, it is best to use the shell method because you don't have to split the integral into two pieces. So I'm gonna do the shell method here. To do the shell method, that means every time you cut, so you're gonna have a cylinder. So every time you cut, you're gonna have a radius R. Radius R, right? You can imagine that you have a cylinder like that. Whoa, this is your cylinder, right? And then that is your radius, and your height gonna be this thing, your height. So that means your shell radius, this is going to be from what you have, which is going to be the y value that you fix, and then minus -2. That is going to be your radius. So which is going to be y plus 2. And then your shell height, this is going to be the red curve minus the blue curve. So the red curve gonna be x equal to square root y. The blue curve gonna be x equal to 1 over y. So that means the shell height gonna be square root y minus 1 over y. So once you have your shell radius and shell height, so the volume gonna be so it's actually gonna be integrated from a to b to pi times shell radius and then times shell height and then dy. All right, we have integrate 2 pi shell radius is going to be y plus 2 and shell height gonna be square root y minus 1 over y dy. And then here you integrate from a to b, so you're gonna integrate from y equal to 1 to y equal to 4, right? Because this is going to be the interval of y that you need to integrate with respect to. Sounds good? So again, your shell is going to be this thing. This is your shell, right? This is your axis of rotation. So the picture, the three-dimensional picture you have to imagine in your head, it's going to be tough if you draw it in the paper. Alright, that is the answer for this question because they just ask us to set up but do not evaluate. Well, on the exam, if the question asks you to show your work by using the watcher method, you have to use the watcher method. Well, if the question asks you to use the shell method, you have to use the shell method. But if the question does not state anything, you can use the method you want, whatever. Alright, so we're gonna end this topic here, and then we're gonna move to the next one, which is the last one for this chapter, which is arc length. So arc length, this is the one that we can compute the length of the curve by using calculus. The formula is here in the box, so let's look at this thing together. So arc length, so if you have a continuous function and the first derivative is defined on the interval AB, then the length of the curve from A to B is given by this formula L equal to integrate from A to B square root 1 plus f prime x squared dx. So this is what you have to memorize and just use it on the exam. So the length of curve is going to be the easy question in the homework and also in the exam. Gonna be one question about arc length. So it just memorize the formula and plug in. So the proof of this arc length formula, you can prove it by using the mean value theorem. Well, for the calculus 1 class, we have not talked a lot about mean value theorem. So we're gonna skip the proof of arc length. Well, but the proof is easy and readable. If you are interested, you can just look at any book of calculus. There must be the proof of arc length. But for the sake of this class, we are going to use it to compute the length of curve first. So, well, let's look at example 197. So we ask you to set up but do not evaluate the integral you would use to find the length of curve fx equal to log cos x between x equal to 0 and x equal to pi over 4. So you just need to use the formula. So the formula says that if you want to compute L, so you can compute by integrate from A to B. Your A here is 0, your B here is pi over 4. So it's going to be 0 to pi over 4. And then you integrate, the integrand is going to be square root 1 plus f prime x squared dx. Well, that means you need to find f prime x first. So from what you have, fx equal to log cos x. Well, this will give you f prime x equal to 1 over cosine. And then differentiate inner function so you get negative sign, right, which is going to be negative tan x. Oh, this is your f prime x. So you can plug in into the integrand here, so you get 0 to pi over 4. So square root 1 plus tan square x dx, right? And then if you want to simplify more, so you can integrate 0 to pi over 4, and then square root 1 plus tan is sec square x dx. Well, this is actually integrate 0 to pi over 4 absolute sec x dx, right? And this is actually integrate 0 to pi over 4 sec x dx, because when x is between 0 and pi over 4, absolute sec is positive. Well, you can stop here if you want, because the question asks you to just set up but do not evaluate, right? But if you want to integrate this thing, you can, because you have the formula. So integrate sec, you get what do you get? Integrate sec, you get log sec x plus tan x, right? Sounds good. All right, we're gonna look at one more question on arc length. Again, arc length is just to memorize the formula, so you don't have to be worried about the format of the question. This is going to be the easy one on the exam as well. All right, so for this question, we have the curve fx equal to x to the 3 over 2. Well, we want to find the length of curve between x equal to 0 and x equal to 4. So we're going to start by differentiate that. So we get 3 over 2 x to the 1 half, right? Now we can, that this is actually 3 over 2 square root x. Now we can compute your L, which is going to be integrate from a to b square root 1 plus f prime x squared dx. Very easy, right? Now you integrate 0 to 4 square root 1 plus f prime x is 3 over 2 square root x, and then you square it dx. So now you have integrate 0 to 4 square root 1 plus 9 over 4x dx. All right, now it's time to integrate. So we're gonna choose, we're gonna do u substitution. So we're gonna choose u. Okay, let u equal to 1 plus 9 over 4x. So now your integrand gonna be integrate just square root u, right? And then once you pick u to be 1 plus 9 over 4x, du gonna be 9 over 4 dx, which means dx is equal to 4 over 9 du. All right, and then after you choose u equal to 1 plus 9 over 4x, so you can think that when x equal to 0, then u equal to 1, and then when x equal to 4, then u equal to 10. So that means your lower bound of integration gonna be 1, upper bound gonna be 10, because you have du now, not dx. And then now you can integrate this thing, which you're gonna get 4 over 9, right? Integrate 1 to 10 square root u du. So square root u is u to the 1 half du. So that means you're gonna have 4 over 9 u to the 3 over 2 over 3 over 2, and then you evaluate at u equal to 10 minus u equal to 1. So the answer is gonna be 8 over 27 10 to the 3 over 2 minus 1. This is going to be your length of curve for this curve between x equal to 0 to x equal to 4. Alright, that is the end of section 7.4, arc length. So to summarize everything about this chapter, well, again, one more time, you don't have much time to digest the material on chapter 7, so it's going to be only 20% on the final exam. So it's going to be, the content that we learn in this chapter is finding the area between two curves, find the volume by slicing. So that means we will give you a cross-sectional area. The you know the We're gonna give you the information about the cross section, so that we cut perpendicular to the x-axis, for example, and then, well, we get the cross section in what shape, so we're gonna give it to you, and then your task is you trying to find the volume, and then we learn how to find the volume of the solid of rotation by using this method, washer method or shell method, and then the last one we find the length of curve. So you can expect these four topics only 20%. So you can expect that, one question on finding the area, one question on finding the volume by slicing, one question on arc length, and maybe one or two question on this and shell method. Does it make sense? Well, and that will count 20% on the final exam. All right. Again, one more time. If the question says set up but do not evaluate, so you do not need to compute the exact value of the integral. Just leave what you just set up to save your time. If you keep doing it, no more extra point, because we can just ask you to set up but do not evaluate. Well, if the question says set up but do not evaluate, you just set up. But if the question asks you to compute, well, you have to compute it. You have to answer the exact value, right? For example, the arc length, we always ask you to compute like that, right? For this question, so you just need to compute because, yeah, this is find the length of curve. So if we want you to just set up, we're gonna say set up but do not evaluate. All right. So hopefully you are ready for the final exam. So we're gonna end the clip here, and then, yeah, let's keep in touch on Monday. All right. Thank you.